Let's talk about cross-site scripting attacks. Cross-site scripting is, without a doubt, the most common modern web vulnerability. It falls into type of injection and happens due to insecure processing of user input. As a result, adversary can execute JavaScript code in victim's browser. Cross-site scripting is attack on the client. It should be noted that it's not attack on a server, like SQL injection or comment injection. By executing JavaScript code in victim's browser, adversary can perform any actions available to user in the context of vulnerable site. For example, read and modify any data available to user, intercept the credentials, and many more. Typically, security experts distinguish three main types of cross-site scripting: reflected, stored, and DOM-based. There is also a passive and active cross-site scripting. In the first case, nothing is required from the user for the JavaScript code to be executed in browser, and in the second case, the user must perform some actions, for example, clicking on specific button. Let's see what reflected cross-site scripting looks like. In such an attack, the malicious string is in the request to the site. The server adds it to the response. In other words, user data is reflected in the page. Assume we have some script that writes hello username. The script gets the username from getParameter. If we write Bob, we will see hello Bob. However, if we write Alice and wrap it in the B tags, then during processing we will see hello Alice, but in bold font. We can see that the script directly outputs an HTML result in the response, and this means it's vulnerable. If we embedded our JavaScript code in the query and the name value, the result of its execution will be displayed on the page and we will get message with 1. In this case, we can say that this functionality is vulnerable to cross-site scripting. It's not always possible to inject HTML tags to JavaScript code. Once again, we send the JavaScript code as a username, which was reflected in the page and executed by our browser. Stored cross-site scripting occurs when the application saves the payload and includes it in subsequent HTTP response. For example, it could be a comment to a record. If user comments proceed without synthesization, the adversary can leave a comment with JavaScript code. Any user who then goes to a page with this comment have the JavaScript code executed. The third type of cross-site scripting is DOM-XSS. It takes place when JavaScript on the client side processed data from the untrusted source in insecure way, typically by writing the data to DOM tree. An injection can also be made in different parts of HTML page or context. For example, if injection is made into tag value, you can use events to execute JavaScript code. Also, an injection can take place in JavaScript code itself. It's very important to see where the injection takes place and what characters are processed. How to find XSS? To automate your work, you can use various popular tools such as Burp or WhatsApp, etc. But for manual testing, it's important to test each HTTP request separately to see whether arbitrary JavaScript can be executed using a specially composed input. To each request, send a specific HTML characters to each entry point of application, and depending on which characters have been filtered and which have not, you can judge whether there is a vulnerability. Test each parameter where the entered data is returned in HTTP responses. Protecting against cross-site scripting can be a non-trivial task. In this slide, you can see a general list of measures. So, let's do some practice.